Hello students, today we are going to learn about the understanding quadrilateral, and this is the 8th class chapter 3 and understanding quadrilaterals. So this is also a very important chapter in the 8th class, and it's also a very good topic as well. So let's see what are the quadrilaterals here, and how we solve these type of issues, these type of problems in the textbook. So I would like to start with the basic understandings first. So like, what is the plane curve? So I'm referring the NCERT book of the class 8. So this is the standard for everyone, so that's why I have chosen this one. And a part of that, we'll see if you have any difficulties in this chapter. Okay, so let's start. So first of all, just what is plane curve? What is plane curve? So anything like anything which is drawn without lifting your pencil from the plane paper, like this, and this. So I have not lifted my pen or the chalk from this board, and I have drawn a diagram. So this is the plane curve. Okay, and we also remember we not need to repeat these lines. So once I have started, for example, this, and this is the square, right? I have not repeated the lines here. Just starting from here, just I draw a closed curve figure. So this is the plane curve, which is also given in the book here, like what are the types of the plane curves, and who is the closed and who is not. So here, if we learned about this simple closed figure, so simple closed figure is nothing but a simply which is drawn and completed there, one origin to the end point meeting to each other. Similarly, if I draw like this, okay, it is given in the book as well, just I am drawing this to make you understood. Okay, understand. So this is the plane curve, but this is not so easy to draw. So that's why it is indicated that a closed curve that is not simple. These are the very simple closed curve. These are the simple closed curve. This is also a simple closed curve, but it is, while making it, it's not so simple. So that's why it is denoted as a closed curve, a closed curve which is not simple. It is closed curve, but it is not simple while making this diagram. So thus we will able to find it out what are the plane curves and what are the simple closed curves and not a simple closed curve. So thus we have completed one topic from the textbook. Now what is polygon? The next topic is what is polygon. So let's write the question here. What do you understand by is a polygon? So it's a very simple. What is polygon? A simple closed curve made up of only one line segment, only the line segment. So anything, any figure, it is given in the book as well. The definitions are also given in the book. You can refer from there as well. A simple closed curve made up of only line segments is called polygon. Okay, so the focused area over here is only the line segment. Only the line segments helps to make any figure. For example, again I am taking the simple curve close, that this is the line segment. What is line segment here? So any line which have two end points, two distinct points starting from A and to B. So this is called the line segment. What is a line? Any line which has no starting and end point, that is the line. What is ray? Ray is having one starting point and there is no end point. Okay, so these are the very simple things which we recapped it now. And of course you are in the 8th class, so definitely you should know all these things. These are the basic things which we learned in the previous classes. So coming back to the topic, that is, what is a polygon? So a simple closed curved made up of only line segments is called polygon. Okay, simple. Anything which you not understood, you can comment me and you can ask me about it. So let's see few examples. Curves that are polygons and that do not. So I'll give you only one example, and just to not exaggerate and not confused. So this is nothing but the curve that are polygons. So this is the simple curved polygon. Okay, and the curve that is not polygon. So this is the polygon curve that which is not considered or not comes under the polygon. So the figure is like this. Let me draw the same as it is given in the book. So it helps you when you refer it. So this figure is given in the book as well. So this is not a polygon. So this type of figures is not considered as the polygon, and this also not a simple curve polygon as well. So these are the examples over here. Let's see few more topics which is given in the textbook as well. So let's see the classifications of the polygon. How you classify the line segmented figures in the understanding quadrilaterals. Okay, so let's the another topic in the book is classification of polygon. So there are many polygons, but we need to classify the polygons. Polygons could be classified according to their number of sides and the vertex. So here 2 point you should remember. The polygons could be classified into the categorization on the 2 facts. The first one is the number of sides of a polygon. Okay, and the second one is number of vertex. So number of vertex. Okay, so these 2 parameters which helps to classify the polygons easily. Okay, so let's elaborate this topic more and see some examples on the basis of the classification. For example, I have one figure that is rectangle, or we can take the triangle first. Triangle. If I draw a triangle here, so this vertex A, B, C, you can name from here as well, A, B, C as well. Just I want to understand you what is the we are trying to say here. So this is the side 1, this is the 1, this is the 2, and this is 3. And the classification of these polygons are, first is the sides. So here sides are AB, AC and BC. Okay, these are the sides. And if I talk about the vertex, so vertex here are this point is vertex A, vertex A, vertex B and vertex C. So these two conditions are is satisfying the property of classification of the polygons. Okay. So similarly, we have many more things, many more polygons. For example, quadrilateral. If I draw any quadrilateral or anything like this, okay. So if I name it A, B, C, D, and the two condition, that is side 1, 2, 3, 4. So side could be right in any ways, like one side 1, 2, 3 and 4. Similarly, I can write the vertices, that is A, vertex A, B, C and D. So similarly, you can also classify the polygons on the basis of the number of sides and the vertex, number of vertex in it. Okay. So next topic is diagonals. Diagonals of a polygon. So what are the diagonals? Let's see. This is a rectangle. Okay. So lines meeting to the opposite vertex. Line meeting to the opposite vertex like this, like A, B, C and D. Okay. So AC, BD. So AC and BD. Okay. So these are the diagonals. And diagonals are nothing but is a line segment connecting two non-conjugative vertex. So non-conjugative vertex are the opposite vertex like A, C, B and D. These are the two opposite vertex. Okay. So diagonals are nothing but the meeting the two opposite non-conjugative vertex of the polygon. So this topic is covered now. Let's move to the regular and irregular polygons. Okay, so next topic is regular and irregular polygon. So what is regular and irregular polygon? So we have two things which classify the regular and the irregular polygons. So when we say this is a regular polygon, we have 2 points. If it is equiangular, and the second point is equilateral. So equilateral is nothing but the equal sides equal of a polygon. Okay. So if two conditions are meeting, first is equiangular, it means equal angles. Okay. For example, this is the square, so it has equal angle 90 degree, 90 degree everywhere, 90 degree, 90 degree and 90 degree. And similarly, equilateral, or all the sides of a polygon are equal. Like this side is equal to this side and this side is equal to this side. So this two condition, if it is meeting the two conditions like equiangular and equilateral, then it's a regular. If anything missing, like if anything is not meeting these two or either one, that is comes under the irregular. For example, if I draw a rectangle, okay, so here the angles are equal, like 90 degree and 90 degree. So what we have like here, the two conditions. One is equiangular and the second one is equilateral. Okay, so here in this rectangle, equal angle is meeting, but equilateral triangle, like equilateral sides are not same all the way, all the sides. Like this side is equal to this, okay, but this side is not equal to this side, so this is not a regular polygon. Okay, I hope you understood like what is the regular polygon and what is the non-regular or irregular polygon. So let's come to the next topic, that is angle sum property. It's very interesting and very important as a point of resolving the equations based on the angle sum property. So our next topic is angle sum property. Okay, so this is nothing but any triangle having angle 1 plus angle 2 plus angle 3 equals to 180 degree. So this is the property of angle sum property. So if I have a triangle here, so angle 1, angle 2 and angle 3 here. So including all these three angles, the sum is 180 degree. Okay. So based on this, I have a question in the book, textbook, NCERT textbook. Let me try to draw this. This is the figure where we have this type of line segments. My drawing is not so good, so just try to understand. Okay, so this figure is also given in the book as well, so you can refer from there as well. Like this angle is 70 degree, this is A, angle A, this is angle B, and this is X, this one is also X, and this is 60 degree, and here is having 30 degree. Okay, everything is done. These are the rays. Okay, so here we need to find it out, the X and Y, the X value of X. We need to find the angle X, okay, X degree. So this is the question. So by applying the various methods which we have learned from the previous class as well, and using the angle sum property, we'll also find it out, the X and Y. So here the first one is like this. If I take this, you remember what type of condition here, like one line segment, on that another line, and forming the two angles. This condition you must remember, like this comes under the linear pair. So according to the linear pair, like this angle and this angle, like 70 plus angle A equals to how much? 180 degree, because this is the straight angle. We can consider this is the straight line, and anything forming angles on the straight line is 180 degree according to the linear pair. Okay, so in through this I'm able to find angle A. This is 180 minus 70, so angle A equals to 110 degree. So I got this one, 110 degree. Okay, similarly I'm able to find it out, the angle B. So angle B and corresponding to this is angle 60, 180 degree. Okay. Similarly, angle B is 180 degree minus 60. That is angle B is equal to 120 degree. So here we are able to find it out both the angles, which is not given, but we know that this is forming the linear pair, and through that we'll find it out this interior angles. So we come across to know here, see sum of angles, or we can also find it out with the polygon sides. This is side 1, 2, 3, 4 and 5. So this angle forming what? Pentagon. This angle forming pentagon. So this is nothing but the pentagon. And pentagon have 5 angles. 5 angles. Okay. So if I take the interior angles of a pentagon, if I take interior angles of pentagon. So the property of the interior angles of a pentagon are, and the sum is 540 degree. This is the total of the pentagon's interior angles. So according to this property, I am able to find it out the value of x, or the angle of x. So let's substitute all the angles in this property. So angle A plus angle B plus angle X plus angle X plus angle 30 is already given over here. Okay, equals to 540 degree. This is the total degree which comes under the interior angles of a pentagon. So angle A, we already know that 110 plus angle B, we already find it out with the help of the linear pair, and here 2x, like here angle x plus x 2x plus 30 equals to 540 degree. Okay, so let's solve this, all these things. So numbers are taking here like 0 0 0, 3 5 and 1 6 and 2. So 260 is the answer of this sum, and we have 2x here. So let's substitute the 540, and if I take all these values there, let me write here. So 2x equals to 540 minus 260. So let's minus it out. This is the 14 and this is the 8. Sorry, this is 14, yeah, this is 6, 1, 8. So this is 4, 14, this is 0, 14, 6, 12, 8, and this is 4, this is 280. So 280 is the, after the minusing it, but we need to find out the value of x. So x equals to 280 divided by 2. This is 140. So, and one of the angle of x is 140 here. So 140, x equals to 140 degree. Okay. So this is 140 and this is 140. Okay. So if you have any confusion, you can add it up, all these things, and find it out. The sum total should be 540. So you can also substitute like 140, 140, this 110, 120, and 30. So let's see. This is 8, 10 and 4. And this is 1, 2, 3, 4. And 1, 2, 3. So here we have like 1 carry. Okay. So this is the 540 total. This is the 8 and plus 1 10 plus 2 10 and 11, and this is 3 14 carry 1, and this is the 540 is the answer. So like this we are able to find it out by applying the various properties. Here is we are applied the linear pair, and here we applied the pentagon angles, like interior angles is 540. So thus we are able to find it out many things, many angles by using this property. So let's see one more thing from the angle sum property. Angle sum property. So if I have a triangle, okay, and this angle is let's suppose 70, this is 30, I need to find it out this. Okay, so according to angle sum property, this is the A, B and this is C. So angle A plus angle B plus angle C equals to 180 degree by angle sum property. Okay, so let's substitute the values. Angle A is 30 degree, angle B is what? We need to find it out. Let's suppose X, and angle C is 70, 180 degree. So this 2 is what? X plus 100, 180. So angle X is equal to 80. You know that how we calculate it. 180 minus 100. So 80. This is the 80. So by angle sum property we find it out the value of the X, or the required third angle. So let's see some more examples from the next topic, that is some of the measures of exterior angles of a triangle. We learned how to find it out the interior angles of a polygon. We are now here to learn how to find the exterior angles of a polygon. So next topic is sum of measures of exterior angles of the polygon. Okay, so let's see directly because we are aware about it, like what are the polygons and what are the exterior angles. So the sum of the exterior angles is nothing but the 360 degree. This we need to remember, like the sum of the measures of exterior angles of a polygon equals to 360. So let's see this topic with the help of one example which is already given in the book as well. So this line goes like that. This is that. This is the line, and this is another line. And the marking is given is here like 50, and this is 110, and this is X, and this is 90 degree. Okay, so here we try to find it out the exterior angles of the polygon. So let's see by substituting the values here, like we need to find it the value of X here, of course. So let's see. So all the exterior angle, the sum of, what is the property of the exterior angle? The sum of measures of the exterior angles of a polygon equals to 360. So I should write angle 50, which is given externally, plus x plus 90 equals to 360 according to the exterior angles of the polygon. So let's calculate once again. This is 160 plus x plus 90 equals to 360. Now again we need to plus these two figures, which is non-variable figure. So what will be the answer? 250 plus x is equal to 360 degree. So x equals to 360 minus 250. So x is equal to 110. You can also minus it out. 360 minus 250, subtract it, 1. Okay, so this angle is 110. If you sum up all these things, we'll get the 360, which is the property of sum of the measures of angles of exterior angles of a polygon equals to 360. So we learned the interior angles and exterior angles of a polygon, and lastly, because everything is covered in this, if you remember all these things, all these properties, we'll definitely able to do all the questions from this chapter, understanding the quadrilaterals. So whatever I have taken the topics, that is more enough to resolve the questions and answers from this textbook. Okay, so lastly is kind of quadrilaterals. Okay, so here we have the kinds of quadrilateral. Here we'll able to understand the properties of the different type of quadrilaterals. First, if I take to the parallelogram, the figure is like this, parallelogram, and these are the diagonals meeting at here. If I name it like A, B, C, D. So how I classify and how I say that this is the quadrilateral, if it's meeting or if it is meeting the properties of the polygon as well and the properties of the quadrilateral. Like for example, in A, the opposite sides are equal. Their opposite sides are equal and the opposite angles are equal. The second one is opposite angles are equal. Okay, and third property is diagonal bisects one another. So diagonals are also need to bisect each other, we can say that. So these are the diagonals, which is opposite vertex, and this is the AC and this is the BD. So like this, if anything which is meeting the properties of these three, the opposite sides are equal, opposite angles are equal, and the angle bisectors are also intersecting to opposite vertex. So this is nothing but the one kind of quadrilateral and its property, and I have taken the parallelogram. You can also see the same thing, same quadrilaterals like rhombus. So B1 is rhombus. So rhombus is nothing but the just is a square and just little bit seems to, and the properties are same as the square. See, all the properties of the parallelogram and the diagonals are perpendicular to each other. Again, the same which is the property of the parallelogram which we have learned, the opposite sides are equal. Okay, and second is opposite angles are equal, and third one is the diagonals to the opposite vertex, like A, B, C, D. So AC is one diagonal and BD is another diagonal. So like this we are able to verify, or you can also write the properties of the other things like the rectangle and this is the, let's suppose this is third, this is 4, and a square as well. Okay, so you can try it by your own, and if finding any difficulties in understanding or applying the properties anywhere, you can comment me in the chat, so in the comments, so that we can answer you accordingly. And if you want me to teach or explain some different or the another chapters in the 8th class, you can also suggest me. You can give me your suggestion as well, like sir, I want to understand this topic or this type of this chapter in the next session. So I'll try to cover those. Like if you want to do here like data handling, we can also do that. If you want the squares and square roots, if you want the cube and cube roots, like comparing quantities, these are the very important chapters in point of view of exams. So this is very helpful. Although we can also work upon the algebraic expression and identities, there are a lot of identities as well. So we can also talk about these identities. And mensuration, it is also a very important chapter in the 8th class, mensuration. Then powers and exponents, then direct and inverse proportions, okay, and factorizations, and many more. So playing with the numbers, number system, and rational numbers, linear equation in one variable. So this type of chapters you can suggest me in the suggestion box, or you can comment me in the comment section, so that I can prepare video for those topics as well. And it's really helpful for you. Believe me, it's really helpful if you understood correctly, if you understood the subject correctly. So you not need any help from anyone, but just you go by your own. So the main motive of my teaching is to just make you understood the concept of the mathematics and nothing else. So enjoy yourself, take care, have a good day.